Good morning. So today I have here an A1932, maybe a 2020, 2019 era Macbook Air. However, the situation with the year and such is kind of irrelevant to what we're doing today. This particular one has two USB-C charging ports or data ports. The other side, none. So it's just got the two. The situation with this one was the battery wasn't charging, so a new battery was put in it by the customer, and to find out that there was still no charge. So they brought it in. Of course, it does turn on. Everything works fine, and it works just on the 40% or so of battery life on the new battery. So obviously, the first thing I did was I backed up the stuff on here in case it's a board issue, because the storage on these is not removable. It's on the board. It's integrated to the board. So if the board has to be replaced, there goes everything. The RAM, the video, the CPU, all on one board. Okay, so first thing to test this is with pretty much most, if not all, USB-C powered devices, whether it's an iPad, an iPhone, a Mac, a vape, pretty much anything. It talks to the device and says, okay, here's 5 volts, and it talks back saying, I am a MacBook, and then it bumps it up to 20 volts or thereabouts, and then starts pulling amperage, which is basically like throughput. If you can imagine like turning on a hose, the amps would be the water moving through the hose, and the volts would be like the pressure of the water, how much water can go through. Anyhow, so if we put this on here, on this particular one, we see that it goes to 5 volts and goes up to 20 volts. You can see that. But if you look at the draw of the amps, it's only 45 milliamps, which is nothing. This thing should be close to 1 or 2 amps draw to charge this battery. So kind of what this tells me is it's got an issue with either A, the charging circuit, or B, it may even be that the port itself is dirty or damaged. So we're going to try that next. So we got 52 milliamps, and we switch it around and put it on the other one, see if we get the same result. 15 volts, and just goes to 20 volts, and then basically like 5/100ths of an amp, 56 milliamps. Okay, so we're going to open this up and inspect the actual USB plugs right here and see what the story is with those. Okay, we have the two USB-C ports pulled out. I will say that this part here that connects to the motherboard was a little bit loose, and these don't look terrible, but they do look a bit worn. So we're going to put these under the microscope, see what we can see. All right, so I have seen in the past where some of these were actually burnt or shorted, which actually caused the entire USB-C circuit to malfunction. These look okay, but like I say, a bit worn. So we're going to clean those. Let's look at the back side here. Yeah, see, it would seem to me that if just one of these was a little bit too worn out, then it could cause issues with the whole circuit. And here is the connector to the board, and that looks absolutely fine. So what I'm going to do is basically just going to clean, put a little isopropyl alcohol on both sides, and use a toothbrush to just scrub these. And you won't see miracles, but you might see enough to actually make this make this circuit function the way it's supposed to. Just keep an eye on that right there and see what it looks like after I scrub it just a little bit. Now, if you notice, a big change. There was a bunch of kind of goop on there that is now gone. And now I don't know what in the world that stuff is there. It's almost like there's some sort of glue or something that got onto there. Really happy with the way this turned out, though. Looks good. Okay, so now we will just take a Q-tip. That looks pretty good. All right, so now before we go any further, I'm just going to reassemble. We're going to reassemble the port and see how our charging looks now. See if it actually pulls some amps. Stand by. All right, guys. So it turns out cleaning those was nice, but it did not fix the issue. Then I got to thinking a little more and realized that it wasn't just a charging issue. It was an issue with USB communicating whatsoever. So I went ahead and pulled the board out. And the very first thing you always want to do is do inspection of the board surface. And I've actually just done this, and I found something quite interesting. You can see some capacitors and resistors up, here, and they kind of look bad, but nothing really out of the ordinary. Because if you look, so many of them look identical, like these ones down here. They all look that way. It's not out of the ordinary. You're looking for something that is starkly different. So I started going down the board here, up and down, and came across that. Okay, we will get back to that in a minute. I just want to check everything else. And if you've ever needed to replace one of these boards, they don't make it easy. Apple does not make it easy to find part numbers and things. They're getting much better, but typically you need something really, really magnified to see board numbers and things like that. You'll see when we get to it. And they purposefully, in my opinion, make it hard to see so people don't attempt their own repairs and they just buy them new ones. So far, the rest of the board's looking great. I mean, there's a little bit of dirt here and there, but the other day I actually fixed a machine simply by cleaning the board. So the other day I just cleaned a board that had a lot of stuff on it, just stuff, and it brought it back to life. All right, and just to be thorough, I will look at the other side of the board as well. I didn't really see anything that stuck out on this side, but you can see all sorts of pieces of hair and lint and just kind of not really corrosion but dust and whatnot. A lot of times you'll see old spills or drops of liquid that get in there that don't do damage but just kind of sit there and cause a little bit of dirt or corrosion. All right, let's see, almost done. And then hopefully we're going to come across a part number for this board just in case we need to order it. That's the US. All right, so that's the video cable right there. And we go clear over here to start the other part of the board. There's the Wi-Fi antenna cables. They look great. Interestingly, there's the very last bit. It actually shows the board number, which is interesting because that one's actually easier to read. All right. Okay, so we're just going to go back to the only problem I found on this board, and that typically is the sign of bad capacitor, probably due to liquid. So what we're going to do is we're going to put a little alcohol in this and clean it. And believe it or not, sometimes cleaning it fixes the problem. Sometimes the corrosion that's there was quite simply enough to bridge a couple capacitors, short them out, so to speak. While I'm at it, I'm literally going to clean the whole board. It will only take a moment. Just basically just go over it to clean off any other little bits. But as you can tell, where the damage, so to speak, was, that looks good. There's a little tiny bit of something here, but I don't think that's a problem. Looks all right. But anytime you're in this deep, it's always a good idea to clean the board if you can. So yeah, that looks a lot better. And I don't really see a burnt cap. Maybe just it was shorted out. But we will find out. I do see something right between here. Ah, okay. Ah, see that? Cap is moving. Okay, sorry, being here at work, a lot of interruptions, so if I seem a little scatterbrained, that's because I'm in between phone calls and things. Okay, so looking at this, obviously this capacitor is fried, totally fried. But it seems to me that this is in what they call parallel. In other words, it's got more than one capacitor here, right? So typically you can usually get away with leaving this other one here that seems to be okay. So we'll take this one off. Wow. All right, so put a little alcohol on this to clean it and see if we can get a little bit better view. Okay, so what I'm going to do is I'm going to grab my multimeter and we'll test to see if those are in parallel. Okay, so what we're going to do was put the multimeter in diode mode, but we're going to do it with a noise, a beep when it's connected. And then we'll go back over to here. And so if we have a connection on something, for instance, right here, this is what they call 0 ohm resistor, essentially a fuse. We have continuity. Okay, so here we shouldn't have continuity, but we do because it seems there's a short because of that. But yeah, we have a short to ground. See right here, we do not have continuity. There's no short to ground here. There's no short to ground there. If we hit this, no short to ground there. None here, none here, none here. But here, none. Here, none. Here and here we have a short. So that tells me it's very possible that this cap is shorted out. So what I'm going to do is I'm going to pull this cap and then test it outside of circuit to see if it's in fact shorted. All right. That would definitely cause this problem. This right here looks pretty bad too, right there. But we're going to leave that for now. And just to give you an idea of how tiny these capacitors are, this is the head of a Q-tip. So you can see that those capacitors are probably maybe 2 millimeters at best. Okay. That one's actually loose as well. So we will just force it off this board. We want to be real careful, of course, but there's not much to that. So now we will actually see. Wow, that's so small. Now we got to find to see if this is actually shorted. So, all right. It's almost too small to see. Yep, we have a short. So, get rid of that. If we go back to the board here, where we found the capacitor issues, we should be able to check this out, and the short hopefully should be gone. Short is gone. That's good news. So, what I want to try is to see if these two are also in parallel, and by doing this, we can test to see if we have continuity here, 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 and here, and also here, 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 and here. If we do, we could probably live without those two capacitors. We might have fixed our problem. So there's that. Let's see if we get continuity. We don't. So that can be kind of a situation where we have to replace these capacitors. However, somewhere else on this board, those could be redundant. We've got several layers, so I'm going to try to see what happens if we put this back in the board and see if it fires up and the USBs start working. Okay, I have it put back together enough to test. This was a really excellent find and a good exercise in kind of finding issues from burnt capacitors. Think about something. This board would have cost something like $300 at least, I'd say. If you look at the battery percentage, it's at, you can see it, 27%. Okay, so now if we plug it in here, we look at the amps, 1.25 amps. So now it's drawing the right amount of amperage with those shorted out capacitors removed. 1.45 amp, perfectly where it needs to be. So we were at 27% on the battery. So like I say, a lot of times you can have redundant capacitors, and I'm not really excited to try to replace those if it works without them. Those things are beyond tiny. Anyway, so with a lot of products, you have redundant capacitors. In this case, we're up to 2.26, which is fast charging, 2.26 amps. And if you look at the, let's see here, I'm trying to get it here. If you look, sorry, there we go. If you look, we're now at 28%. So the battery is going up. It is charging. And so this would be one that I would just finish up, put back together, call it a day, and call it fixed. And it was, we just saved an entire motherboard, so good deal. All right, guys, that's going to do it for this one. Hopefully you've learned something. Now, this one obviously won't fix everything on every board with this issue, but this is how we narrowed it down using our voltmeter and just our eyeballs. Have a great day. We'll see you in the next one.